Okay, students, precipitation reaction. What is precipitation reaction? I give you one example. If I make an NaCl solution in water, because here in chapter number 4, we shall discuss only aqueous solution. So we always make our solution in water. Our solvent will be water. Okay, I make another solution by dissolving AgNO3 in water. Now, we have two solutions. This is NaCl solution. This is AgNO3 solution. Mix these two solutions. I put this AgNO3 solution here in this NaCl solution. When you mix these two solutions, what happens? After mixing here, you will see white solid substance in the bottom. This solid substance that is separated out from these two solutions is known as precipitate.
Yes.
And the reaction between these two solutions, AgNO3 plus NaCl, AgCl plus NaNO3. This reaction is known as precipitation reaction. Upon mixing of two or more than two substances, when a solid substance is separated out, is known as precipitate, and the reaction between two or more than two solutions is known as precipitation reaction. Now, my next question is, what is this solid substance? Which one this one? What is this compound? This solid substance. When AgNO3 reacts with NaCl, AgCl is formed and NaNO3 is formed. Now tell me, this is AgCl or NaNO3? Which one is this solid? It is AgCl. Why it is AgCl? Because this AgCl is insoluble in water. That's why it becomes a solid. This NaNO3 soluble in water, that's why you cannot find this NaCl. But you will see this AgCl as a white solid.
Can you repeat?
Yes. When you mix AgNO3 and NaCl solution, it is NaCl solution and it is AgNO3 solution. Now what happens? When AgNO3 reacts with NaCl, AgCl is formed and NaNO3 is formed. Now this AgCl is insoluble in water. Now if it is insoluble, it means it will change to solid. It will remain as solid. So when it forms AgCl, then it becomes white solid and it remains in the bottom in a solid. Now this solid is known as precipitate. Now this AgCl is precipitated out. Okay, students, now our next topic is how to write ionic equation and net ionic equation about precipitation reactions. So these are some steps how to write. I will show you. This example is taken from your book. Predict what happens when a potassium phosphate solution is mixed with the calcium nitrate solution. Write a net ionic equation for the reaction. Okay, students, in all precipitation reactions, what happens when you write any precipitation reaction? Suppose I write A, B. This solution reacts with C, D. The precipitation reaction first always attach with the second. And this first attach with this second. So how will be the reaction? AD plus CB. This first positive ion attaches with this second negative ion, and this first positive ion attaches with this second negative ion. Now after that you will find which of these is soluble, which of these is insoluble. Okay, now I will show you here. Let's solve this example. What is the question? When potassium phosphate, now listen it carefully. When potassium phosphate mix with CaNO3 twice, what happens? Now, you have to complete this equation. You have to balance this equation. Okay. Then you have to write ionic equation. Then you have to write net ionic equation. I will tell you what are those. Now, first, let's complete this equation. It's very important. Now, what I told you before. First, potassium reacts with NO3. When K reacts with NO3, it becomes KNO3. How? Because charge on K +1 and charge on NO3 -1. +1 and -1 same charges, they will be cancelled. So your correct formula is KNO3. So be careful about writing correct formula. Okay. Now this first calcium reacts with PO4. So how? When calcium attaches with PO4, charge on calcium +2 and phosphate -3. 3 comes here, 2 comes here. What is correct formula? Ca3
BO2,
PO4
BO4
PO
twice.
twice.
Very good. So Ca3 PO4 twice. This is your correct equation. So be careful for writing the correct formula. Don't write KNO3 twice. You have completed your equation. Your first step is complete. Okay, now move to next. You have to balance this equation. How to balance this equation? Boys, before going to balance this equation, you have to tell me it is soluble or insoluble. If I ask A3PO4, it is soluble or insoluble? A3PO4.
Soluble.
You will write AQ. AQ mean aqueous. It is soluble. If K3PO4 is soluble in water, then you will write it is AQ. So K3PO4 soluble or insoluble?
Soluble.
So you will write AQ. Okay.
If it's insoluble, what should
If
I
it
write?
is insoluble, you will write S. S means
S?
solid. Yes.
Okay. Okay, thank you.
Yes. Okay. CaNO3 twice. Soluble or insoluble?
Soluble,
Very good. It is soluble. Why?
because in O3 twice.
Excellent. Because of NO3. Very good. You will write AQ. Good. Excellent. KNO3 soluble or insoluble?
Soluble.
Why?
Potassium.
Very good.
Potassium
First group
ion.
present. Very
Yes.
good. Ca3PO4 twice. It is soluble or insoluble?
Soluble.
Insoluble. Insoluble.
Insoluble.
Why it is insoluble? Why?
Yes.
Because of PO4.
BO4.
PO4. Yes, it is insoluble. You will write S. Okay, friends, when you complete this solubility and insolubility, you will write soluble AQ, AQ, AQ for soluble, and for insoluble, you will write S. Okay. After that, you start your equation for balancing from solid S insoluble. How many Ca?
3.
How many Ca here? 1. Multiply this Ca with 3. Okay. How many PO4? PO4 total?
8.
8.
2, 2, 2, 2. Boys, PO4.
Oh.
I have 1 PO4.
2.
How many now it becomes? 2. So 2 PO4. Here, how many PO4? This 1. So this side 2, this side 1. Multiply this with 2. Now, boys, listen. You have balanced your equation, your left side of the equation with insoluble here, insoluble compound here. It is okay. Okay. Let me. Okay. You have balanced your left side with this solid compound. Don't touch this left side. It is balanced. Now, we have left only one compound, KNO3. How many K here?
1.
1. How many K here?
6.
6. Multiply this K with 6. Your equation is balanced. So you see how it's easy. Start from insoluble compound and balance all left side with this. And after that, after balancing left side, you have only one compound and also balance this one. And if you see NO3, it is automatically balanced. Okay. Now, okay, students, our next part of this question is ionic equation. Ionic equation. What is ionic equation? Boys, for writing ionic equation, you will change all these aqueous compounds to ions. How many potassium here? First change into ions. 6K. Okay. And how many PO4? 2 PO4, because this 2 will multiply with this PO4. So 2 PO4 plus how many calcium here?
3.
Very good. And how many NO3? Very good. 6 NO3. Now you will write the charge. Positive, it is minus 3 plus 2 minus 1. It gives us how many K here?
6.
How many NO3 here?
6.
How many Ca here?
3.
3.
Boys, listen. You will change into ions only that is AQ. You will not change solid. Okay, so you will write as it is Ca3 PO4 twice as it is. Don't change into ions. Okay. Now you will write AQ, 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 here AQ, here AQ. Now this equation is known as ionic equation. Any question from your side? Yes, boys.
Last part, doctor.
Now I told you, you will change this AQ compound to ions. Now you see here, all these AQ, this one AQ, this one AQ, this one AQ. It is changed to ions, positive and negative. But that is solid compound. You will not change into ions. It will remain as a solid. Now this equation is known as ionic equation. Boys, now move to next. Now tell me which ions are same on both sides.
Potassium. Yes, potassium.
Is
Nitrate.
it? Very good. 6K plus 6K plus. Both are same. These will be cancelled.
Also
6
nitrate.
NO3 minus 6 NO3 minus cancelled. Very good. Now what is left? 2 PO4 3 minus plus 3 Ca 2 positive. It gives us Ca3 PO4 twice solid. And we write it AQ, AQ. Now, this equation is known as net ionic equation. Net ionic equation. Okay. So, though after cancelling of same ions on both sides, what is left? 2PO4 3 minus plus 3 Ca2 positive. It becomes calcium phosphate. So, this equation is known as net ionic equation. Now, tell me, which ions you have cancelled here in ionic equation? K positive and NO3 negative. These ions are known as spectator ions. The ions which are same both sides in ionic equation, that You have already cancelled. These are known as spectator ions. Now, any question? Basically, these ions don't take part in chemical reaction. That's why we say these are spectator. Spectator means they are not taking part in a chemical reaction. So these are spectator ions. Yes, any question from your side, boys? No question? MashaAllah. You see how it's easy. If you have any question in your mind, you can ask me. You have to perform these 5 steps. Number 1, you have to complete this equation. Number 2, you have to balance this equation. Number 3, you must write this ionic equation. Number 4, you have to write this net ionic equation. Number 5, you have to tell me the spectator ions. These 5 steps. So let's complete another equation. When a lead nitrate solution PbNO3 twice reacts with sodium iodide. Now, you have to complete this equation now. How will you complete? I told you first ion will attach with this second. This is positive. When lead attach with this iodine, what is the charge on lead? 2 positive, and iodine -1. So 1 comes here, 2 comes here. What is correct formula?
I2.
I2. Very good. Okay. Now second, this sodium, this positive ion will attach with this NO3. And what is the correct formula? Sodium +1 and NO3 -1. So +1 -1, they will be cancelled. So correct formula will be NaO3.
NO3.
Very good. Excellent. NaNO3. Okay. Now you have completed this equation. Now you have to balance this equation. How will you balance this equation? Okay. Okay, students, before balancing, I told you you have to find it is soluble or insoluble. Now lead nitrate, it is soluble or insoluble?
Soluble?
It is soluble due to nitrate, NO3, NaI, sodium iodide. It is soluble or insoluble?
Soluble.
Soluble.
It is soluble due to Na. Very good. It is soluble or insoluble?
Uh, insoluble.
It is
Insoluble.
insoluble. It is solid. Why? Because this iodine attached with Pb. So it is insoluble. NaNO3, soluble or insoluble?
Soluble.
Soluble. Very good. Okay. Now, how will you balance this equation? You will start with PbI2. How many Pb here?
1.
1. How many Pb here?
1.
1. It means it is already balanced.
Yes.
How many iodine here?
2.
2. And how many iodine here?
1.
1.
1.
But we put
Multiply
2.
this. Very good. Okay, friends, now you have balanced this left side with this solid. Now we have left only one compound, this NaNO3. How many Na here?
2.
2. And how many Na here?
We multiply by 2.
Very good. Now your equation is balanced, boys.
Yes.
Now you see how it's easy. Okay. Now what is next? You have to write ionic equation. How will you write ionic equation? Change all these into ions. Pb2 plus, and how many nitrate here? 2 NO3 negative plus. How many sodium? 2 Na positive. How many iodine? 2 I negative. Iodide ions. Now, how many Pb?
1.
Okay. And how many iodine?
2.
I told you solid, you will not change. It will remain solid. How many Na?
Okay.
And how many NO3? NO3. But you will change only aqueous, AQ. You will not change any other. AQ, AQ, AQ. It is also AQ. Now this equation is known as ionic equation. Now which ions are same on both sides?
Nitrate
Nitrate.
and sodium.
Very good. So 2Na plus will be cancelled. 2NO3 negative will be cancelled. So what is left? Tb plus 2I minus, it gives us TbI2. It is AQ, AQ, it is solid. Now this equation is known as net ionic equation. Okay, okay friends, now what are spectator ions?
NO3
No.
and Na.
Very good. So Na positive and NO3 negative, these are spectator ions. Any question, boys?
Clear this one.
No, it's clear.
Everything is
Thank you.
okay? Very good. Excellent.